Hello and welcome to the Met Office Deep Dive. All year we've been waiting for high pressure to turn up. When it finally does, it arrives in October and it's a cloudy high. How long though will high pressure stick around, and will it ever give us some sunshine? I'll be trying to answer those questions in this week's Deep Dive. Thank you for joining me on YouTube or on the Met Office app, and it's at this point that we normally ask you to hit subscribe. It allows us to do more videos like this Deep Dive, which has been going for almost 2 years now. And we always read your comments, we always take on board your feedback. One request has been popping up time and time again, and we've been working behind the scenes here at the Met Office to make that request a reality. Unfortunately, I can't say any more right now, but if you are interested in what this mysterious request is and what we've been doing to make it a reality, you have to tune into next week's Deep Dive, and we'll explain more at that point. But without further ado, again, please do hit subscribe, send us a like, send us a comment, because you never know, one of your suggestions might become a reality. Now, I mentioned that it's a cloudy high, but it's not cloudy for everyone. Let us know in the comments if you've seen some sunshine through the day, because some areas have seen. This is the satellite image at 1 p.m. Tuesday the 29th of October. A lot of cloud, as you can see, but some areas are a bit more favoured than others for sunny skies. Most notably, if I just draw on some weather symbols here, you can make a bit more sense of it. Some parts of eastern England, eastern Scotland, seeing decent sunny spells, whilst, well, as you can see, western Scotland, a lot of low cloud, some hill fog, some mist, and so on. Now, the reason we've got a better chance of sunshine through eastern Scotland, northeast England, is because we've got this westerly airflow. So that's leaving a lot of low cloud across western Scotland, but of course it's then breaking up over the hills. Further south, the cloud breaks are somewhat more random because we haven't got that same mechanism. The winds aren't coming so much from the west. We've got high pressure more or less centred over the top. And so, yeah, there are a few cloud breaks out there, but they're not particularly organised or particularly reliable. They're a bit more tenuous. They're floating here and there, and that's really the theme across southern parts of the UK over the next few days, because high pressure has arrived and it's here to stay. To explain how we got into this situation in the first place with high pressure in charge, let's go back to the beginning. Let's go back to Thursday. And in last week's Deep Dive, I was talking about how the jet stream was expected to become increasingly amplified, increasingly wavy across the Atlantic, and that we'd see a cut-off vortex form that would eventually lead to higher pressure. And actually, this is visible now in the satellite imagery from the last few days. We can see what happened. In fact, I'm going to try and annotate what happened. This was Thursday's satellite image, so clear skies across eastern parts of the UK, cloudier further west, and this long string of cloud out to the west. But if I draw the shape of the jet stream, which you can almost trace these areas of cloud to draw it on, the jet stream came out of Newfoundland there and then came south, and it's at this point that it came really elongated and then rose across Ireland there and then into Scandinavia. So you can see how wavy it is. And it's within this area that you can also see an emerging area of low pressure, this cloud head here, and these big shower clouds also forming. Skip forward to Friday, and indeed that area of low pressure did form just by here. And around that low we had an upper area of low pressure, so where the jet stream cuts off from the main flow and starts rotating in a almost full circle. Meanwhile, the main flow of the jet stream, again, continued to come out of Newfoundland there, but upon reaching that cut-off low, well, one branch dived south, one branch went well to the north of the UK. And fast forward to Saturday, now the cut-off low basically ended up around here somewhere. The jet stream again, by the way, there's a point here where ex-hurricane Oscar pushed the jet stream well to the north into the Davis Strait, and that helped to amplify the jet stream. But what we saw on Saturday was, again, two branches of the jet stream coming around like this, and effectively, like a stone in a stream, there's your cut-off low, and it splits the jet stream into two like that, one branch going to the south and forming a subtropical jet stream over North Africa, and then we've got the polar jet stream going to the north of the UK, and higher pressure forming through the UK, although this branch of the jet stream, by the time we got to Sunday, as you can see, we've got it coming into the UK like that, and there's another area coming down like that. So this area of the jet stream brought some wet weather into Western Scotland and Northern Ireland through the second half of the weekend before sinking south. And this is what we ended up with. Again, a very elongated jet stream just to the south of the UK now. And by Monday, what that resulted in is another cut-off vortex from the main flow, whilst the main flow of the jet stream is now well to the north of the UK. Now this is of interest, this cut-off low over Iberia, because since the start of the week we've seen some very heavy rainfalls, some thunderstorms and some lively showers, and that circulation is going to stick around over the next few days. I'm going to talk about the expected rainfall amounts in a short amount of time. Meanwhile, with the main flow of the jet stream going well to the north of the UK, well, we've got high pressure building across the country instead. And here's how it looks for Tuesday afternoon. There's that low pressure over Iberia, over North Africa, and just to switch on the rainfall there, you can see some heavy outbreaks of rain rotating around the low, but the wettest weather, as I'll explain in a bit more detail in a moment, eastern parts of Spain. This cut-off area of low pressure, also known as a cold pool, because it's a cold pool of air in the upper atmosphere that drifts over warmer surface levels, can lead to an enhanced temperature gradient from the warmth at the surface to the cold air way up at the height of the jet stream, and of course that triggers some very lively convection or thunderstorms, and that's what we're seeing. So it's an upper cold pool, and what it is often known as in Spain is a Gota Fria cold pool. So that's a well-known phenomenon occurring often actually at this time of year. There was a famous flooding event that brought devastating flooding to Valencia in 1957. Similar sort of phenomena with high pressure extending from the Azores towards the UK, and this cut-off area of low pressure bringing a lot of wet weather. And I'll talk a bit more, like I say, about the expected rain in Valencia in just a moment. But for the UK, we've got high pressure extending now in the jet stream well to the north, and just playing that forward over the next few days, and you can see really there's very little change in the bigger picture. The jet stream stays to the north. Diverting weather fronts. Here's a series of weather fronts that start life in the mid-Atlantic, and you can see a deepening area of low pressure here that is starting to move with the jet stream, but because the jet stream is to the north of the UK, that frontal system will also remain mostly to the north of the UK. But if I pause it there, this is Wednesday evening. What you can see, there's an area of low pressure near Iceland. A little bit of uncertainty about exactly how far from Iceland it will be. But we've also got on the southern flank of that low, tightening isobars across central and northern Scotland. So that's going to lead to increasingly windy weather Wednesday night into the start of Thursday. The weather front, meanwhile, brings mild air across the UK, although it has to be said, by the way, that the colours here reflect the temperature at 5,000 feet. Why do we choose 5,000 feet for this? It's because it shows quite clearly areas of similar weather, air masses, that's what they're called. And so we've got this warmth, this warm air mass that originates towards the southwest of the UK, extending across the UK. But at this time of year, you can often have very different circumstances towards the surface of the ground rather than at 5,000 feet, and it won't be nearly this mild. The reason for that is because cloud breaks at night will lead to lower temperatures where we get those cloud breaks because of the increasing length of nights, and also because the relatively low cloud during the day will prevent solar insolation. So yeah, either way, if we had this situation in the summer, don't mean to rub it in, but if we had this situation in the summer, it would be very warm indeed. In fact, going into next week, you'll see how the weather pattern next week could lead to some really quite warm weather in the summer or the spring. But because it's happening in November, mild, yes, but not particularly extraordinary temperatures. But the temperatures at 5,000 feet are well above average for that height, whilst we've got the blues marked there towards Iceland, and the fronts here acting as the boundary between the cold air to the north and the mild air to the south. And what happens through Halloween is that these fronts bring some rain and the strong winds to the north of Scotland. Meanwhile, the rest of the UK is basically under high pressure still. As the cold front starts to sink south, later Halloween, the blues start to sink south. And so later, and then into the 1st of November, we've got the blues starting to make an appearance into the far north of Scotland. But that's as far as they get, because another pulse of warm air in the Atlantic, almost heading directly north, courtesy of these areas of low pressure, mean that the fronts over the UK are also deflected eventually to the north. And these fronts weaken as they come south as well, because higher pressure builds back in. The reason higher pressure builds back in is because of this pulse of warm air to the west of the UK that then comes in over the top of the country. Why are we getting this big pulse of warm air across the mid-Atlantic? Well, I'm going to be exploring that towards the end of this, and it's something to do with thunderstorms over the Pacific. But in the meantime, for much of the UK, it's a relatively benign period. I'm just going to take a quick look at the weather summary over the next few days, and what you can see with these 4 charts here. Pressure chart with the jet stream well to the north of the UK, high pressure building in for the rest of Tuesday. Here's the cloud map, and that's the important thing, because that will make a difference in terms of overnight temperatures, daytime temperatures, how it will feel. However, with high pressure virtually centred over the UK, these areas of cloud are just going to be floating around slowly and aimlessly with no particularly strong winds to break them up, with the exception of eastern Scotland, as already mentioned. Those westerlies across the far north of the UK are helping to break up the cloud for eastern Scotland. But elsewhere across the UK, it's tenuous areas of cloud drifting here and there. Variable amounts of cloud, best way to sum it up over the next few days. The cloud will have a few spots of rain and drizzle, particularly over western hills, most especially western Scotland, Tuesday night into Wednesday. Temperatures, yeah, they'll dip into the single figures if we get cloud breaks. Otherwise, by the start of Wednesday, 11, 12, 13, nothing particularly exciting. Now, Wednesday, this is 2 o'clock, high pressure centred over the UK, a lot of cloud, but you can see some cloud breaks, southeast England, northeast England, more extensive cloud breaks, sunny skies for much of northern and eastern mainland Scotland. Just some patchy rain pushing into Shetland and Orkney. That's the front making its first appearance later Wednesday. But winds are light. That's what this map in the middle is showing. Light winds at this stage. Then the wind arrows start to pick up there across northwest Scotland, and it's through the hours of darkness on Wednesday night. You can see these colours. These are areas of 50-mile-per-hour gusts or above. So just heading into the far north of Scotland. There's the jet stream, there's the frontal system, tightly packed isobars, and some outbreaks of rain into Shetland, bits and pieces of rain for western Scotland. Further south, it's more of the same. Wednesday night into Thursday, we've got variable amounts of cloud floating here and there. Where we do get cloud breaks on Wednesday night, there'll be some fog patches for the start of Thursday. But yeah, otherwise they'll clear through the morning. And then Thursday, this is 2 o'clock, so Halloween, mid-afternoon. And it's breezy in the north of Scotland, light winds elsewhere, outbreaks of rain into the far north of Scotland, mostly light but some moderate rain, front starting to sink south, and some cloud breaks, but otherwise a lot of cloud across the country. Temperatures 14, 15, 16 in the south, 13, 14 further north. Then fast forwarding to Friday, similar sort of time, and what you can see is the front has sunk south across Scotland, Northern Ireland. The jet stream is becoming more amplified once again, but we've got colder air coming into the north, so into the single figures Friday afternoon into northern Scotland. The winds are coming from the north, but that brings some brighter skies. So after the damp weather on Halloween, the 1st of November in northern Scotland, at least, is looking a little drier and brighter. The front, though, is coming south across central and southern Scotland, Northern Ireland. It's weakening, light and patchy rain, and then it just basically fizzles out as high pressure builds back in. Now, that high pressure is with us into the weekend, but by Saturday, it's starting to move to the east of the UK. As a result, what you can see on this graphic, and more so on Sunday, are southeasterly winds. Southeasterly winds coming from the continent could be more reliably drier and clearer compared with the Atlantic flow that we've got over the next few days. So you can see a greater chance by the start of Sunday of some cloud breaks developing across England and Wales. That means that for southern parts of the UK, although there'll still be variable amounts of cloud coming and going through the weekend, there's perhaps a better chance through the weekend of some sunshine. Further north, we've still got a large amount of cloud for Scotland, Northern Ireland, particularly Western Scotland and Northern Ireland and over the hills, but some good cloud breaks there for the northeast, for Aberdeenshire, for example. Temperatures dipping a little bit by the weekend. Let's take a look at temperatures, actually. This is the temperature trend over the next few days, and really it's, spot the difference, it's low to mid-teens across most of the country. The one big difference there is northern Scotland by Friday, and in fact we can take a look at that on a graph. So London, a small downward trend in maximum and minimum temperatures through the next few days. Maximum on the top, 16 down to 13, 11, 12 Celsius by the weekend. Minimum temperatures there down to the mid to high single figures by the weekend. Edinburgh, similar sort of trend really, just a couple of degrees lower. But if we click somewhere further north than that, so this is a point in the far north of Scotland, and you can see by the start of Friday, low single figures possible. Just move the map up here and go to Shetland, and yeah, mid to low single figures possible by Friday morning. Temperatures do recover in the north of Scotland actually by the weekend. So although there's this gradual decrease in temperatures for England and Wales, I think for Scotland and Northern Ireland, the lowest temperatures will be around Friday with that brief northerly. And then as high pressure builds back in again, those temperatures recover. Just want to quickly look at wind speeds as well, because I mentioned that winds are peaking Wednesday night into Thursday. This is a summary for each day, so the maximum wind gust for each day over the next few days. But we can pinpoint the time at which those winds peak, and as you can see, it's 5 a.m. Thursday. Now, it's picking out there exposed parts of northern Scotland, but we're also likely to see, particularly through Halloween, these westerlies or southwesterlies are going to be colliding against the hills and then bouncing on the other side of the hills. So that's what we call lee gusts, lee gustiness. It's where you've got stable air because we've got high pressure. And so as the wind gusts push, or as the strong winds push against the mountains in the west, they're forced up, but high pressure is trying to keep a lid on activity because high pressure is sinking air. And so as those winds are forced to rise over the mountains, they're then forced back down again by that high pressure as they descend over the mountains to the east, and that causes some buoyancy, basically. They rise over the mountains, they're forced back down by high pressure, and then they overshoot somewhat, so they rise again, and then they descend again, and you get this lee wave activity, so this ripple in the atmosphere. And wherever the winds are descending, you get a peak in wind gusts, and that can happen, say, over eastern parts of Scotland. So there's the risk, basically, eastern Scotland through Thursday and early Thursday of wind gusts of 50, 60 miles an hour. So that's something that we'll be monitoring closely over the next few days. But of course, for the rest of the UK, it's not windy at all. It's very light winds, hence the variable cloud floating here and there. And just want to talk specifically about Halloween weather, because you might be making plans, you might have kids, you might be going out trick-or-treating. So let's take a quick look at that. Oh, that's the wrong graphic. Still getting used to this. Please bear with me. Okay, that's the one. Skipping forward to Halloween and assuming you're going out just after dark, which of course at the moment is about 5 o'clock. Here's how it's looking across the UK. A lot of cloud, basically, an awful lot of cloud. Some thick, low cloud across western parts of Scotland, giving some drizzle, and we've got that strong wind as well across Scotland. Breezy for Northern Ireland and Northern England, but not quite as strong as further north. And we've got more persistent damp weather for Shetland, Orkney and the far north of Scotland, the Outer Hebrides. But elsewhere across the UK, it's dry. There'll be some breaks in the cloud. They'll be somewhat random again, especially in the south. You can see some breaks being picked out there for southern counties of England. Could be a bit more extensive. It's difficult to say at this stage because these breaks are going to be so tenuous and random. But if we put on the temperatures, you can see it's going to be fairly mild. 12 Celsius, 11, just about anywhere you pick, it's double figures, whether you've got the drizzle or the strong wind or the low cloud and so on. So mild, a lot of cloud, but most places dry for Halloween. Nothing particularly spooky about that. I'll tell you what is scary though, the thunderstorms that we are seeing across Iberia at the moment. And I just want to show you some of the rainfall totals that are taking place here. Now the eastern part of Spain is the focus for the heaviest rain. And although these will be in the form of thunderstorms and heavy showers, so it's difficult to pinpoint exactly where we're going to see the liveliest weather. It's really through Tuesday and Wednesday, so the rest of today and into Wednesday. This is showing the rolling rainfall accumulation, so as it's playing, it's showing the rain adding up through time. And what it's picking out there is in excess of 150 millimetres of rainfall across eastern parts of Spain. So some really exceptional rain totals. And as it plays through, you can see those areas getting a little bit bigger. I think that, yeah, there we go. There's a spot there that's in excess of 200 millimetres, and I understand there is that risk of 200 to 250 millimetres of rain accumulating. And Valencia is around here somewhere. These are areas that are really quite populated, so this amount of rainfall, with the additional risk of tornadoes, waterspouts, large hail, flashes of lightning, could cause considerable impacts over the next few days because of that cut-off vortex, because of the Gota Fria situation that the Spanish call it, and those slow-moving areas of showers and thunderstorms. Meanwhile, there are also areas of thunderstorms across the Western Pacific. Let's take a look at those. And there is a reason. These are significant. Let's zoom out a little bit. Okay. And if we go to the daytime, there's an area about here of enhanced tropical convection, enhanced rainfall. So we've got thunderstorms on the other side of the planet. We've got thunderstorms in Spain on Halloween. These, you might say, are spooky types of weather, thunderstorms. So hence the thumbnail title, Spooky Action, but at a distance from the UK. Those fans of quantum mechanics might also recognise that phrase because it's a phrase that Einstein used to describe quantum entanglement, and that's the phenomenon, a really strange phenomenon, whereby subatomic particles can share the same information or observed to do the same thing, but be, many thousands of miles or light years apart, even though information can't travel that fast between the two of them. They've got no apparent means of communicating between each other, and they still somehow influence each other at that great distance. And Einstein said that violated the law of physics, that nothing can travel faster than the speed of light, and so he called it spooky action at a distance. That's why I used that as the title for this week's deep dive thumbnail. Clickbait for Halloween enthusiasts and quantum mechanics enthusiasts. I'm not going to go into any more detail about quantum mechanics, you'll be pleased to know, mainly because I don't understand any of it anyway. But I thought it was interesting because this area of enhanced tropical convection is connected to the UK's weather next week. But that's where the similarities between the weather forecast and quantum entanglement finish. Because there is a connection, and it doesn't happen instantaneously. There is a mechanism by which this rain influences the UK's weather. This is a teleconnection. Teleconnections, we've talked about them plenty of times before, are things like El Nino and the quasi-biennial oscillation. There's plenty of these teleconnections that meteorologists look at, and they're basically weather or climate phenomena that can happen thousands of miles away but have an influence on the UK's weather. And this particular teleconnection is called the Madden-Julian Oscillation. Unlike the El Nino teleconnection or other similar teleconnections, this one happens at sub-seasonal timescales, so at timescales of a few weeks to a month or two. And it was only discovered relatively recently, actually, back in 1971 by Roland Madden and Paul Julian. What they discovered was there's this travelling area across the globe of enhanced tropical rainfall and suppressed tropical rainfall, and it slowly moves from west to east at about 4 or 5 metres per second. Here's an illustration of enhanced tropical convection over the Indian Ocean. You've got this strong upward motion, which then results in this strong downward motion 1,000 miles or so away over the West Pacific. Now, this area of enhanced tropical convection would slowly move eastwards at about 4 or 5 metres per second. And we end up with 8 known phases of the Madden-Julian Oscillation. That's what it's called. Phase 1 to 8. And this basically describes that enhanced area of tropical convection as it moves around the world. It circumnavigates the world. Although it's strongest when it appears in the Indian Ocean and the Pacific Ocean, it kind of loses a lot of its identity as it moves through the Atlantic and Africa and so on. But it can influence tropical cyclone activity and African rainfall. So, Phase 1 shows it starting to appear in the Indian Ocean. That's what this is showing. And what you're seeing here, the greens and then into the blues, are where it's wetter than average. And here, just off the coast of East Africa, we've got Phase 1, wetter than average weather into the eastern or the western part of the Indian Ocean. And then it really, through Phase 2 and Phase 3, it really gets going across the Indian Ocean, this big area of blue. Phase 4 then sees it move into the maritime continents. That's much of Indonesia, North Australia. Phase 5 shows it's really taking off across Indonesia, Borneo, and North Australia. Phase 6 then takes it into the West Pacific. Phase 7 continues its journey across the Pacific. Phase 8, it tends to weaken as it moves further east across the Pacific. So we've got this travelling wave of enhanced precipitation through the Indian and then through the Pacific Oceans. Why is that important? It's important because it does all sorts of funny things to global weather patterns. It influences rainfall in California. It influences the Indian and Australian monsoons. It influences tropical cyclone activity, and it increases or decreases the chance of high pressure over the UK. And that's shown by this diagram. This is a paper from 2008 by Christophe Cassot, and it's in Nature. You can see the full reference at the top there. Now, just to summarise this very briefly, because I know there's a lot to take in, this shows different weather patterns for the UK in 4 different columns. The left column here is the negative North Atlantic Oscillation. Basically, that's high pressure near the UK or just to the north of the UK, to put it simply. The next column is the positive North Atlantic Oscillation. That's where we've got stronger westerlies over the UK. So in the winter, that can lead to more storminess. It can lead to milder and wetter winter. It's what we've seen a lot of in the last 18 months, basically. Then in the third column, it's the Atlantic ridge, so big area of high pressure across the Atlantic, and often northwesterlies or northerly winds for the UK. And then we've got a Scandinavian high pressure, so that's where we've got easterlies or southerlies for the UK, but still an area of high pressure nearby. The strongest relationship, as is shown by this paper, between the Madden-Julian Oscillation phase and the weather patterns over the UK are from phases. So the phases are listed here. We've got phase 1, which is a relatively weak phase, but then by the time you get to phase 3 and 4, where the Madden-Julian Oscillation really intensifies over the Indian Ocean, what that's linked to, and what that's showing here with these orange columns coming out, is that you're more likely to get stronger NAO positive phase for the UK, stronger westerlies, more likely, not guaranteed by the way, there's a lot of other things going on with the UK's weather. This is just one relationship with the UK's weather. So phases 3 and 4, where you've got enhanced tropical rainfall over the Indian Ocean, you get a greater chance of westerlies for the UK rather than high pressure. The opposite is then true by the time you get to phase 6 and more especially phase 7, and that's what's shown by this here, is that as that enhanced area of rainfall moves into the maritime continent and then more especially moves through Western Pacific, you get an increased chance of higher pressure near the UK, more likely to the north of the UK or perhaps directly over the UK, a negative North Atlantic oscillation. But there's a lag effect, and it's reckoned that when you get into phase 6 of the Madden-Julian Oscillation, when it's going from Indonesia into the West Pacific, 10 days later, 12 days later, you're more likely to have weaker westerly winds for the UK, higher pressure over or to the north of the UK. More likely. Not guaranteed. Like I say, there are lots of other things going on with the UK's weather. But what we are indeed seeing, and another complicated diagram here for you, but this basically shows how the Madden-Julian Oscillation phase has changed during the last 40 days and how it's expected to change in the next few weeks. The black line that goes around, I'd say it's a line, it's more of a circle, isn't it? It starts off 40 days ago, 19th of September, and it shows a dot in this quadrant, the West Pacific. So the last time we saw enhanced tropical rainfall in the West Pacific was the 19th of September. Then it moved around the world. So if you imagine it's circulating around the world, going through all these different places, West Hemisphere and Africa, and then down here we've got the Indian Ocean, and then it's moving through the maritime continent in the last week or two. And now, the current time, it's going from phase 6 to phase 7, so it's well and truly in the West Pacific. So it's at this point that you can add on a week or a bit longer and say, okay, that's when we can expect weaker westerlies, if that's the only thing that was influencing the UK's weather, which of course it's not. Then, into the first few days of November, the phase moves into phase 8, and then phase 1, which are typically phases that don't really influence the UK's weather. So it's at that point that we can't really use it for predicting the UK's weather. But we're already in phase 6, going into phase 7, as I mentioned. And so let's take a look at that and how it looks. And why does it influence the UK's weather? That's what I want to address, basically. We've got this enhanced area of tropical rainfall now, and that at the top of the atmosphere, well, at the top of the troposphere where the weather takes place, we've got these towering cumulonimbus clouds, a tremendous amount of energy being lifted through this convective process. So all these towering thunderstorm clouds, and what you notice if you took a temperature reading of the upper troposphere, where the tops of these clouds are, is that you've got a lot of cold air up here, and that's because you've got all this energy being taken from the surface, and as it rises, it cools, and by the time it gets, these towering cumulonimbus clouds, by the time they get to the top, they're very cold indeed, and that's just indicative of how much energy they hold. So at the top of these clouds, you've got a lot of cold air, and you've got a lot of energy leaving the top of the troposphere. And that has a ripple impact, a ripple effect on both hemispheres, and in fact the jet stream of both hemispheres. And one of the things that it tends to do when it's in the West Pacific and it's producing all this energy in the upper troposphere is it influences the shape of the jet stream then. It's almost like these ripples are coming out and just bumping into the jet stream in the North Pacific. And it leads to a more wobbly jet stream, basically. That's what happens. And what we're seeing at the time of recording is this very loopy jet stream over the North Atlantic. And in particular, I want to draw your attention to this diving segment of the jet stream, this elongated trough over western parts of North America. And if we just fast forward slightly, what you can see is that that then eventually has an impact on the other side of North America. It's more evident, in fact, if I take off the jet stream and put on the temperatures. What happens is this area of warmth then pushes north over eastern parts of North America during Wednesday and into Thursday. So this area, this is what we're watching. Because of that trough digging south, we've then got on the other side of North America this rising plume of warmth moving into North Newfoundland. And that then squeezes this area of cold air, which is basically, again, this dip in the jet stream. As a result of that squeezing, we see another one of those cut-off upper vortices here. And that results in the jet stream being pushed even further north across Iceland and north of the UK. So here's the jet stream cut-off vortex. And it's at this point, remember at the start I said that warm air was moving north. That's because of that very elongated jet stream on the other side of the Atlantic pushing the warm air north, which allows higher pressure over the UK to be reinforced. So after that temporary cold spell for the far north of Scotland, higher pressure gets reinforced, and the result of that is that higher pressure moves slightly east, but it's here to stay for some time. So all of that stems to how wobbly the jet stream is over the Pacific, and that is related to that enhanced area of tropical rainfall. And the beauty of this is that meteorologists can look at the phase of the Madden-Julian Oscillation and can say, okay, that increases or decreases the chance of westerlies, or increases or decreases the chance of higher pressure over the UK 10 days ahead. So it's one of the tools in our toolkit, but of course it's, as is always the case, never that straightforward with the UK's weather. There are many other factors involved in determining the UK's weather, so it doesn't always play out as straightforward as that. But yeah, I just thought that was a particularly fine example. What does all that mean for our weather going to the weekend? Well, high pressure is here to stay, as I said. That reinforcement of the high and, well, just allowing the centre of gravity to push further east means that the high becomes centred over Central Europe or Scandinavia, and we've got this southeasterly airflow, and that continues into Monday. This is a 71% probability for Monday's weather, and it shows higher pressure near the UK, most places dry, rain being kept well to the west, and some cloud breaks, I imagine, some decent cloud breaks. But as far as temperatures are concerned, nothing particularly extraordinary. Fast forward to Tuesday, 5th of November, bonfire night. If you're making plans for watching fireworks or whatever, this is an 86% probability. So looking a week ahead, it's remarkable to get an 86% probability on one of these types of weather patterns. And by the way, the second and third most likely weather patterns were virtually identical to this. So very high confidence actually into the start of next week that we'll have higher pressure to the east of the UK, keeping weather fronts at bay. But these weather fronts are edging closer, as you can see. And by Thursday, you can see just some signs of some wetter weather into western parts of the UK. And there are some signals now emerging in the model output that we'll see a weak front move in during Wednesday, Thursday, perhaps to bring some outbreaks of rain into western areas, but it's weakening, it's moving into high pressure. Then, well, after that, it becomes a little more uncertain, but this is the most likely weather pattern coloured up for each day out to the next 2 weeks. So we've got Tuesday the 12th of November on the end here. Strong indication of these types of weather patterns, which are Scandinavian high weather patterns. That's what this colour is throughout next week. There's also this colour coming into the mix. That's high pressure centred over the UK. So basically, all of these reds or oranges are showing that there's this strong signal for high pressure near the UK, whether it's over the UK or just to the east of the UK. We'll see, but that's what the strong signal is. Then, just a hint there of some blues returning by the 11th or 12th of November. And it's at this point, around middle of November, that we've lost that useful signal from the Madden-Julian Oscillation. And so there's a good chance that the likelihood of high pressure decreases. But of course, we'll keep you updated right here at the Met Office on all of that. It's probably more than enough from me. Thank you once again for joining me, and join us again for another deep dive next Tuesday. Bye-bye.